My name is Gautam. I was at Uber previously, currently at Guitar. I was there for 10 years doing developer tools. I spoke at a lot of previous droidcons in New York and SF regarding a lot of build-related topics. And this is Lazaro.
Hi, I'm Lazaro. I was also previously at Uber, worked a bunch on the static analysis tooling, some of it in open source, and I have a PhD on working on static analysis tooling before, so continuing kind of that trajectory.
Awesome. So the key takeaways we want everyone to have from this talk is code maintenance takes a lot of time. I don't know if you've noticed, but it does take up a lot of developer time. We also noticed that automation is key to solve this problem, but it's actually very hard to do reliably, and we'll talk about why. And we also talk about how we at Guitar are thinking about code maintenance and how you can do the same. So I think there was a talk previously about Kotlin 2 K2 compiler. I saw a few raise of hands on who uses K2. How many folks have K2 in their apps? Very low. So if you ask someone this, like usually it's like, oh, it's pretty awesome, I'm really excited. But you're usually not looking forward to all the issues you got to deal with. I think the folks from Meta spent like 3 years doing this journey. And I was like, wow, that seems like a lot for someone to achieve. All the version conflicts, the breaking APIs, the build tooling, the IDE issues. And this is just for K2, right? Like if you imagine like in general maintaining like your dependencies or your migrations, which are never ending. Who's done a migration in the last, I don't know, 3 months over here in your code base? Okay, so you're not migrating enough. Enforcing best practices or cleaning up stale flags can take up a lot of time. And if you ignore these things over time, just like if you don't go for like a health checkup, things start getting bad. So your code quality comes down, your reliability suffers, apps become slow or janky, and stuff becomes outdated and no longer maintained. And you got to have a lot of cognitive load for developers that come into the code base dealing with a lot of legacy code and tech debt. And that leads to unhappy developers, and that's not good. And if you think you can just put some process into the mix, hey, let's just do like a dedicated sprint and get rid of all the code tech debt, and then let's move on. Usually it ends up as sporadic, and sometimes if you're not done regularly, you might have a code red or a code yellow, all hands on deck, fighting fires. It's not fun for everyone. So the key is automation. As you've seen, like in many cases, like as much as you can automate, the better your outcomes will be, and you can get that 30% of time back and increase the developer happiness and ship more features instead of maintaining code. But a lot of the automation today is not that great. So we noticed that a lot of automation in the market is usually, hey, here's a problem in your app which has a security issue. Please go fix it. Or here's a flaky test. Can you go take care of that? And it's very hard to get developers to switch context and go tackle this if it keeps happening fairly regularly. As your code base grows, it's going to keep happening more and more often. And it's also not always well integrated and not always cross-language. And it is a hard problem, as I mentioned, doing it reliably, accurately, covering all the use cases and doing it in a scalable way is hard. And if you don't do these things, developers lose trust in automation. You might think it's that tool again that's doesn't know what it's doing, or something which like an LLM that's like maybe just hallucinating, right? And to showcase why it's hard, Lazaro is going to take over a use case that show you like some of the intricacies behind migration.
Yeah, so why is it hard? Let's look at a very classic example of a migration. Let's look at like a JUnit 4 to JUnit 5 migration. And if you just glance at it, well, the path to the test annotation changed, and you have to rewrite before class to before all, and run with becomes extends with, and the class with is different. But all of this, well, you could do it with set, right? It's find and replace. Just change one annotation name to another. Well, not so fast. If you even look at just the JUnit 4 assertions versus JUnit 5 assertions, you'll notice this very simple change here where the order of the arguments changes. Just doing this will already break all the tools that you try to use with set to do the migration. It will break the regular expression-based approaches for this translation. You need to do something that involves a parser already for something like this. And if you want to do, instead of JUnit 5 assertions, you want to do hamcrest, well, that becomes a little bit more complicated because one method becomes assert that here, the generic method, with a specific matcher. So now there's multiple things that change for the same method, and you need to remember to add all the corresponding imports. And does it get more complicated than that? Yes, of course it does. If you have a task that that you want to assert throws an exception, well, in JUnit 4, that's just a field on the test annotation. On JUnit 5, you need to wrap the entire thing inside a lambda, pass it to assert throws, pass the exception class. So you are getting into a little bit more complicated code rewriting patterns. And what happens if you want to use the runner API directly? If you want to say, like, I want to control how the tests run, well, then this 2 lines of code here become this whole recipe here. And how you would actually migrate that is, well, you'd have to look at the documentation, you have to look at the Stack Overflow answers, maybe you ask an LLM and then spend some time fixing out whatever the LLM spits at you. And rinse and repeat for any migration that you need to do. And that's one case. Like, how about you want to remove some stale code? You have a feature flag that you just rolled out 100%, and you want to remove all the code that was guarded by the condition of that feature flag that you no longer care about. Well, you can remove the actual feature flag here, but then for all of its usage, you need to replace it to whatever value you set the experiment flag to. So let's say true. And then you need to do Boolean simplification. You need to simplify control flow, delete unreachable statements, find out which methods and classes became unused, and remove those 2. And you're basically doing a bunch of stuff that a compiler would do for you normally. And you have to do it for multiple languages just to get rid of this flag. Because if you have, most companies, like, you would have code bases across different languages and different frameworks, all using the same set of feature flags. So how do we automate this process? Well, while at Uber, we built this tool for polyglot code transformation, a code transformation framework that is cross-language, with actively maintained, it's in open source. We have built a bunch of stuff on top of it, though, at Guitar. But if you want to know, like, the nitty-gritty details, there is a paper we published in this at PLDI, which is Top Programming Languages Conference. And however, the summary that you will care about is what it did for us at Uber. It allowed us to remove over 500,000 lines of code in around 2,000 PRs, most of which require no manual changes in a period of 6 months. And this got estimated to be about equivalent to 29 developers working full-time just on removing stale feature flags. So the interesting thing is that you can do this too, and you can do it better, and Gautam's going to tell you how.
Thanks, Lazaro. So as Lazaro mentioned, like, there is this tool that you can use, obviously, the tool in the open source. There is some DSL you can write that specifies the before code and how it gets transformed to the after code. There is a bit of a learning curve. So we thought, okay, what if we took it a step further and made it very easy to integrate with? So that's what we did at Guitar. So we took that tool in the open source, we built a product around it where instead of having you write the formulas yourself, what we do is, like, we kind of package up all those recipes of migrations and feature flag cleanup, dead code cleanup, and we just create the PRs for you. So if, let's imagine you have, like, a security issue or something that needs to get migrated, the stuff that Lazaro showed previously, the JUnit migration and the feature flag cleanup, are out of the box. So they just work. So you can just ask the bot to migrate for you. And we also have built a lot of integrations. So if you have your own feature flagging system or your Sonar cubes or your sneaks or launch darklies, you can get a webhook from there back to us. And then we would basically then act on that change and then create a PR for you as well. And we don't just work with GitHub. We work with, like, GitLab, Stash. We also have an IDE plugin based on LSP into VS Code, Studio, JetBrains IDEs. So you can use that plugin also to, like, migrate code or, like, do, like, spot checks and cleanups. So that's kind of how where we have taken that tool. And as Lazaro mentioned, it's polyglot, which means there is no restriction on languages. If you have monorepo, which I think a lot of folks are having these days with backend, front end, Kotlin code calling into Java code, some stuff defined in one language or configuration picked up from a proto file. We can pick it up from different places and propagate those values and do the cleanup. And since it's based on a very sound compiler and static analysis, it is always supposed to be accurate and gives you a PR that's most likely going to build on the first try, as Lazaro showed. And of course, we have to build something on top of that with AI. So what we have done with AI specifically is, since we have all this information from the compiler that can really provide very rich context about what a value for a particular field can be, and also what is the exact piece of code you should be looking at. So you can slice the program to look at just the part that matters and not the noisy stuff around it. And then we can use then AI on top of it to take decisions for ambiguous cases. For example, there are cases where we clean up code and there's a test you might be using for a feature flag. We may not know if we should clean up that test or not. You might have other logic in there. So in those cases, we of course can also ask AI, but we also have the bot check with the developer on the review, hey, do you want us to clean this method? Yes, no. And the bot can then go and say, okay, I'll act accordingly. So based on the strong compiler foundations and building in intelligence about the framework, so understanding things like dependency injection, JUnit, or even flow, how does the actual operations map in the framework, gives us an advantage in terms of understanding what the code is doing, not just how it looks like. So the key takeaways, I think we mentioned a few times, is it takes a lot of time to do code maintenance. Automation is key, but it's very hard to do. You can do it alone, but it's also much easier to just have someone do it for you. So we do have a booth outside. We have some demos that we can showcase. We'll be in the lunch area later. So if you want to check out the demo, you can play with the laptop. You can do some migrations. You can do some cleanups. Feel free to stop by. We'll be happy to talk to you. Yeah, and that's it. Thanks, and time for questions.